All right, this is going to be a pretty interesting section right here. Like I said earlier, we have factored polynomials before, okay? It's, like a trinomial and stuff like that, difference of two squares, all that good stuff, all right? But these are going to be a little bit more because everything we've done up to this point, pretty much, unless you factor out a greatest common factor, pretty much all our factoring has been a quadratic, okay? It's been a squared, x squared. But now, what? Here. All right, what was I saying? Yeah, just quadratics, but now we're going to do more. We're going to do cubes, fourths, maybe fifths. I don't know if we'll do fifths on here. Probably not. Yeah, but we're going to do up to fourths anyway, all right, which is something that you would have not been able to do before. So let me start off doing this. This thing is called the remainder theorem. Let me do a couple things first, and then I'll talk about the remainder theorem. Okay, so here we go. I'll call it P of x. A lot of times we call it f of x, right? We've done functions, right? Yes, okay. But this time I'll call it P of x for whatever reason, just because the book did, all right? So 3x cubed minus 4x squared. Now we're not going to factor this just right this second, but we're going to warm up to it a little bit and show you something that's kind of important. So there's a little bit of preparation before we do the actual factoring, all right? We actually talked about this yesterday. Remember that one problem where I said I think it was in here, when we did that, yeah, it was, when we did that division, and it came out to a zero remainder, remember that? And we said, oh, that must be a factor then because it's a zero remainder. Remember that? That's kind of what we're going to deal with today. So what I want to do is I want to find out if I divide, how do I want to say this? Let's do this. Let's say if I divide this by x minus 2, is my remainder, or what's my remainder going to be? Okay? I don't have to do the whole entire division to figure out what my remainder is going to be. This is basically what the remainder theorem says. If I put, instead of P of x, what's my k? Do you remember this is x minus k? What's the actual k? Is it negative 2 or 2? It's 2. So what I'm going to do is I'm going to put in P of 2. All right? So I don't have to do the whole division. I can just take that number right there, put it in for x, and let's see what I come out with. If I come out with 0, then x minus 2 is a factor. If I don't come out with a 0, then it's not a factor. Okay? So that's what I'm going to do. So I look for that number, P of 2, and that means anywhere I see an x, I'm going to put a 2. So let's see what we get. We get 3 times 2 cubed. We get minus 4 times 2 squared plus 2 times 2 minus 8. And let's see what we get. I'll save you all the work, and you get a 4. Is a 4 a 0? Obviously not. So is x minus 2 a factor of this polynomial? No, it's not. So it does not divide evenly. If it divides evenly, then what's my remainder going to be? It's going to be a 0. Okay? Here's another way to find the remainder. You could actually do the division. All right? But we can do the division a lot easier than what we did in that problem from the homework we just went over. So what's an easy way to divide this by x minus 2? Synthetic division. So what's going to be in my little box right here? Just a 2. And now what do I put here? 3, negative 4, 2, and negative 8. Now watch. You should get the same exact number when you get a remainder, because if this indicates that that's a remainder, then when I actually do the division on it, I should get the same number as a remainder, shouldn't I? So let's see if I do. All right, bring that down. Multiply it, that's a 6. Add them up, you got a 2. Multiply those, you get a 4. Add them up, 6. multiply them. That's a 12. What's negative 8 plus 12? Did I do that right? Yeah, that's 4. And what is this? This is my what? This is my remainder. Check it out. I got the same remainder by putting that 2 just in for x as I did when I did the division. That's kind of interesting, don't you think? It's not earth-shattering, but it's kind of interesting that you can figure out what your remainder is by just taking that letter k, right, that value for k, and just plugging it in for x. You get the same remainder. Sometimes it's easier to just plug it in and get the remainder. For some people, they would rather do the synthetic division to find the remainder. And that remainder can be very, very important, and especially if that remainder is a 0. That's what we're looking for. We're looking to see if we can get a remainder of 0. Why is that? Because that means if this came out to a remainder of 0, then guess what? This is one of, not the only one, but it's one of my factors. All right, so if I wanted to factor this, I know at least one of the factors. But is it x minus 2? No, it's not, because this is not 0. So if it's not 0, this is not a factor. So let's tell you what. Example 1 is pretty much like I just did. I'm going to skip example 1. All right. Let's go. So that was basically our remainder theorem right there. And so we're going to combine it with a thing called the factor theorem. And it seems very similar to the remainder theorem. I don't know if I can give you the best explanation in the world for this, but I'll show you how to at least do it, okay? Basically, what the factor theorem says is what I just said over here. If your remainder was, let me start this way. Forgetting all my words, the remainder theorem, okay. The remainder theorem just says that whatever your remainder is by dividing, it's the same thing if I put that number in for the x. That's what the remainder theorem basically says, okay? The factor theorem says if my remainder comes out to be a 0, then that x minus k is a factor of my polynomial. You hear that? All right, so that's what the factor theorem, I'm not going to write it all down, but if it comes out to be a 0, then that x minus whatever or x plus whatever, that's going to be one of my factors. So let's do a problem, example 2, and let's put them both into play here. All right, so this is example 2. It says determine whether, I'll just write it down. Just looking at the clock because I'm running out of time already. If I wouldn't tell all my Amish stories here. Determine whether x plus 2 is a factor of this polynomial. I'll put it down here. P of x equals. So I'm not really factoring it just yet. I just want to see, is x plus 2 a factor? We're kind of doing baby steps before we actually start factoring it on our own. Because they're just asking you a simple question. They just take this kind of randomly and they say, is that thing a factor of this? So I got to multiply a bunch of stuff together in order to get this. Is this one of those things that's going to be in that multiplication? You get that? All right, so that's what we're trying to figure out. All right, so we got two ways to do it. All right, because I want to see if this thing comes out to a 0, right? I want to see if the remainder is 0. So I got two ways to do it. Let's do it both ways, and then you can choose whatever way you like the best. So what's one way you could do it? You could put P of what? Negative 2, good. Because remember, this is x minus what? Negative 2. So whatever you're subtracting from the x, that's what you're putting into this, okay? So what are we going to do? Put it in negative 2. So negative 2 to the 4th plus 2, times a negative 2 cubed plus 2 times negative 2 squared plus 3 times negative 2 minus 2. I'll save you the work. This actually does come out to be 0, right? You can do all the work if you want, all right? This does come out to be 0. So what does that tell you about x plus 2? It's a factor of this whole thing right here. By the way, I don't know if I mentioned this or not. Your lead term, your highest power term, okay, your highest degree term, that tells you how many answers that you're going to get. So if I wanted to solve for x, because we are going to factor it, but we're also going to solve for x, right? How many factors am I going to have? How many values for x am I going to have in this situation? I'm going to have 4 of them. For a quadratic, how many answers did you get? You got 2, right? Because it was x what? Squared. What if I have x cubed? How many answers are you going to get? 3. X to the 4th, 4. Make sense? It's pretty easy to see how many answers you should be getting. Now, every once in a while, though, some of those answers will be the same answer. So it may look like you only have 2. Remember we did that yesterday? We got 4 answers. Was it you guys? Or maybe it was the other class. I don't know. Anyway, let's just keep going. What's another way I could figure out if that's a factor? Synthetic division. So let's do that. Let's just see if it really does work. So what am I putting in that little box right there? -2. And then put your coefficients. 1, 2, 2, 3, -2. Drop that down. And then let's do it. You can do this pretty quick now, can't you? -2, add them up, 0. Multiply, 0. Add them up, 2. Multiply, -4, add them up, -1. Multiply, 2, check it out. That's a 0. You see that? They both came out to 0, which means that x plus 2 is definitely a factor of this whole big polynomial. So that's the first thing you need to realize. We're going to use this step in another problem a little bit later, all right? It's really, really going to be helpful. So yes, is your answer. Yes, x plus 2 is a factor. Which means it's just one of the things that's being multiplied in order to get this thing right here, all right? So really, what are we going to have? We're going to have like this would be 1, 2, 3, 4. There's 4 things that are being multiplied. I know at least one of them. What's one of them? X plus 2 is going to be one of them, okay? We got to find the other 3, but that's down the line, all right? So we got another theorem, and it's called, man, I wish I had like 20 more minutes. That's all I need. It's called the rational root theorem. And again, I'm not going to write it all out. If you saw how it's all written out in the book, it looks so confusing. It's like, I have no idea what that means. I'm trying to make this as basic and easy as possible, okay? So what we're going to do, I tell you what, I'll just show you how to use this with an example, all right, instead of trying to talk about it before, because you'll have no idea what I'm talking about unless you see it used in an example. So the question says to factor. Now we're actually going to factor a polynomial, all right, using the stuff that we've learned already. So factor this polynomial. So it's going to be x cubed minus 3x squared plus 5x minus 6. Now, before now, there's no way you could have factored this. There's no way, all right? There's nothing in common. You can't do it by grouping. There's no greatest common factor with everything. So all the ways that we know how to factor something, you just can't do it. But now, what I'm going to do is this. The rational root theorem says this. See that number right there? I'm going to call that P. See the coefficient in front of this? What is it? It's a 1. I'm going to call that Q. All right? So what the rational root theorem says, there's a way to list out your possible factors. They don't all work, but they're in there somewhere. Okay? These are possible factors, and this is what you do. If you take P over Q, you take all the factors of P, divide it by all the factors of Q, that will give you your list of all the possible. Not all of them are going to be factors, but it's going to be in that list somewhere. They're going to be factors of this thing right here. I know that may not make a lot of sense, but once you learn how to do this stuff and you go back and listen to what I just said, It'll make sense, okay? So here's what I'm going to do. I want to take the p, which is what? 6. I want to find all the factors of 6. Like, what times what is 6? All right, what's the smallest number that you're going to use? Like, what times what is 6? 1, okay? And it's not just positive 1. It could be negative 1, because you could take a negative times something else, right? Another negative. Make sense? So all of these are going to have plus or minus. So you could have a 1. What else is a possible factor of 2? 2, right? 2 will go into 6. What else divides into 6? These are all plus or minus, okay? So this is included with all of these, okay? So 3. What about 4? Does 4 go into 6? No. 5? No. What? 6. And that's it. You with me on that? Okay, what about the Q? In this case, this is kind of easy one. I don't even think they do any with a number other than 1 on these. Later on they will, and that gives you more possible factors. It gives you more things to think about, okay? But what are all the possible factors of Q? It's just 1, right? So all this over 1, it's just all that anyway. Make sense? So I'm just going to do this. So what is this? These are all the what? What do I keep saying? The possible factors. Doesn't mean they all work. Okay, these are possible factors. So how do I know which one? I've got 8 of them to choose from, don't I? Why 8? Plus or minus, right? So I got 8 to choose from. How do I know? Well, I just start with the smallest one first, okay? So how do I know if positive 1 is a factor? I could do one of two things. We just finished doing that. I could just plug it in, right? Or I could do a synthetic division. You don't have to do both, but you can pick whatever you like the best. It seems like a lot of people like just plugging it in, all right? And that's fine. Let's do it that way. So what am I going to do? I'm going to put P of what? 1. Just put the 1. If that doesn't work, when I say it doesn't work, what does it need to come out to be? It needs to come out to be 0 in order for it to be a factor, okay? Again, these are all possible factors. My factors are all in here. I just don't know which ones they are. So I got to just pick some and see which ones work. All right. So I just start at the beginning. I pick 1. So what's this going to be? It's going to be 1 cubed minus 3 times 1 squared plus 5 times 1 minus 6. And I think I do all that. This comes out, I'll just tell you right now, it comes out to be a negative 3. I'll just save you the work. You can do that on your own. So is x minus 1 a potential factor? No, it's not, all right, because 1 doesn't work, okay? So what's the next one you're going to try? Well, let's try negative 1, okay? You could try 2. You could try 6. You could try 3. Doesn't matter. I like to start with the smaller ones and just work my way up, okay? And most of the time, you're not going to have to do 4 or 5 of these things. You do 2, maybe 3, all right, before you find your first factor, okay? But let's try negative 1. If I put a negative 1 in for all of this, again, I'm just going to save you the work. If I put a negative 1, this all comes out to negative 15. See what I'm doing? I'm putting negative 1 in for all the x's. I just saved you the work and told you it's negative 15. And then I try, what's the next one I'll try? Try 2. All right, put a 2 in for this. 2 cubed minus 3 times 2 plus 5 times 2 minus 6. And lo and behold, that comes out to be a 0. You're going to have to do the work on it, okay? But I just am trying to make it go faster. So that's a 0. So what does that mean? That means that this, I'll put a little check mark right there. That means that 2 is a factor, all right? Or what's it going to be when I put it into this? It's x minus 2 is a factor. I always like to write this down just to remind me. Is a factor. So what does that mean? That means that this thing right here, this polynomial, if I divide it by x minus 2, it's going to come out even, right? It's going to come out with no remainder. So watch what I'm going to do. I'm going to take that 2. I'm going to do synthetic division, and I want to find out what's left over. If I factor out an x minus 2 from this, I want to find out what's left over. And this is how I do it. I do it by synthetic division. So what's my coefficients? 1, negative 3, 5, and negative 6. And let's do this. We can do this pretty quick now. Bring down that. That's a 2. That's a minus 1. It's a negative 2. That's a 3. That's a 6. That's a 0. So we Yeah, we talked about this yesterday. That's my remainder, that's my constant, that's my x squared. So what is this? This is x squared minus x plus 3, and this is being multiplied by x minus 2. See what we did? So now, since we only had an x cubed before, now it's kind of easy. So now I can actually factor this like the old-fashioned way. All right, so I know this is part of my factoring. What's this going to be if I factor that? Got an x and an x. Bell's going to ring, but just hang on for a second. So what do I get here? I think it does. Hold on. Oh, no, what? It doesn't. That does not factor. This doesn't factor, does it? 3 and 1, is there any way to get a negative 1 out of a 3 and a 1? No, so this doesn't factor. A lot of times it will, okay? That's what I was thinking. So you would have to break it down into that. So those are your factors. Okay, these are all your factors of that polynomial, and that is your answer. So that's the kind of stuff that we're going to be doing. There's only one more example before we get to the other stuff. We'll hit that at the beginning of class tomorrow, that one last example. So remind me, example 4, okay? Example 4, let's do that tomorrow, and then we'll hit the other stuff. Try to do as many of these as you can from the homework. Your homework is 17 to 24. My guess is you'll probably, yeah, this is the A part. You should be able to do just about all of these, okay? You should be able to do all of these. So it's 17 to 24, and it's section 6.6.